Okay, so for problem number 7, we decided to go with a probability counting tree thing because it was the easiest way to go about this problem. So as you can see right now, we're drawing out the counting tree. So instead of using heads and tails for the tree, we're using the floor number that would be landed on given the chance of heads or tails. So if you can see, if it goes up, that's the equivalent to it being a head, and if it goes down, it's equivalent to it being a tail. So we're only drawing out half of the counting tree because we know that if she gets tails on her first coin, she will go down to the 5th floor immediately, and that would not fit the necessary requirements for the problem, which says she must stay on the 7th floor or higher for her entire trip. One thing that we know really quick is that the total number of possible routes she could take would be 32, because there are 5 times that she flips the coin, and each of the coin flips has 2 possible outcomes. So you multiply 2 together 5 times, just 2 to the 5th, which is 32. So it would be 1 over 32 of the probability of any given route happening. So there are 32 total ways to end her trip. So we're almost done with our counting tree. Okay, so we are now done with our counting tree, and you can see that at the bottom we will circle any of the routes that are possible. So this first route here, you can see that's all 7, so that's a possible route. Same with this one, it's all 7 or greater. Same with these 2, as well as, that's a 7, not a 1. So same as these 2. So that's 6 good options, I guess, out of 32 possible options. And that can be further simplified to 3 over 16, which is the answer to the problem.
And then the other side's wrong because the first number is below 7. So.
Yeah. So anything on this side is incorrect because the number is below 7. So none of those solutions would work. This is the first. Okay. So the next problem, number 8. Okay. So 2 circles, one of radius 5 and the other of radius 2, are tangent at point P. So we're drawing a point there, and then 2 circles. One circle, and solid circles. And then here's our other circle. So the radius of the circles are 5 inches and 2 inches, again. So I'm just going to label that there really quick. So if 2 bugs start crawling at the same time from point P, which is here, which is this point right here, that's point P. Then one crawling along the larger circle and one crawling along the slower circle, or the smaller circle, and they're traveling different routes. The one traveling along the larger circle is traveling at 3 pi inches per minute. So you can see we're writing down the circumference of these circles. So circumference of the big circle would be 10 pi, and the speed of the bug traveling along the circle with 3 pi. So then for the second circle, the circumference would be 4 pi, and the speed would be 2.5 pi. So next thing we're going to do is we're going to divide these numbers to figure out how long it'll take for the bug to make one complete loop around the circle. So the pi's cancel out, and for this first the larger circle, takes 3 1/3 minutes to travel around the full circle. Minutes, C, I guess, minutes per circle. And then for the smaller one, it is 1.6 minutes per circle, or 1 2/5 or 3/5. Okay, so the next thing we want to do to figure out when they will meet again at point P is to find the least common multiple of 3 1/3 and 1 3/5. To do that, you can use your calculator, your graphing calculator, because this is target round. you can use two things. You can use the table function, or you could use the least common multiple function. But however you do determine the least common multiple of those two numbers, you will find that the least common multiple of them is 40. So then we figure out that after 40 minutes, they will again meet at point P. So the answer is 40 minutes.